Welcome to The Explainer. Today, we're tackling a massive question in the world of self-driving cars. How do you actually prove a robot is a safe driver? I mean, really prove it? Well, the answer is way more complex and honestly kind of mind-boggling than you'd probably guess. Okay, so let's just start with a number. A really big, really important number that kind of sets the stage for this whole conversation. Every single year, right here in the US, around 40,000 people are killed in traffic crashes. I mean, just let that sink in. It's a huge public health crisis that we've somehow just gotten used to. So, you've got to ask, right? What's causing all this carnage? Is it bad weather? Faulty brakes? Nope. Overwhelmingly, it's us, the people behind the wheel. The research is pretty clear on this. A staggering 94% of crashes are caused by human error. Someone's texting, they're tired, they just make a bad call. The car itself, that's almost never the problem. And that right there is the grand promise of autonomous vehicles. Think about it. They never get drunk, they don't get tired, they're not scrolling through social media. The whole goal is to engineer the single biggest weak link in the chain, us, the human driver, right out of the picture. The potential to save thousands upon thousands of lives is just immense. But okay, this brings us to the absolute heart of the problem. It's a huge puzzle. If we're really going to hand over the keys, so to speak, and put our lives in their hands, we need proof. We have to know for sure that these things are safer than we are. So, how in the world do you get that proof? Well, the most common answer you hear is pretty straightforward, right? Just drive them. A lot. Rack up millions, maybe even billions of miles on real roads and let the data speak for itself. It sounds pretty logical on the surface. And yeah, that's exactly what the big players are doing. You look at companies like Waymo, and they've already logged well over 100 million miles of fully autonomous driving. They point to these massive numbers as, Exhibit A for their safety and progress. But here's the twist, and it's a big one. The RAND Corporation, a really respected research group, dug deep into this question, and they came to a pretty startling conclusion. They found that when it comes to the things that matter most, fatalities and serious injuries, you simply cannot drive your way to proving safety. It just doesn't work. Okay, so let's break that down. Let's really get into why just counting miles is basically a statistical dead end. And I'm telling you, this is where the numbers get astronomical. All right, let's start with just the baseline. To prove, with real statistical confidence, that a self-driving car is just as safe as a human, not even better, just the same, it would need to drive 275 million miles, with 0 fatalities. To put that in perspective, that's already more than double the total miles Waymo has driven ever. But come on, perfect performance is probably not going to happen, right? So what if we just want to accurately measure its safety record? Figure out its actual fatality rate with some precision. Well, this is where the number just explodes. You'd need to drive 8.8 billion miles, with a B. And here's the real kicker, the final hurdle. To prove with high confidence that an AV is just 20% safer than a human, not twice as safe, just 20% better, it would have to be driven 11 billion miles. So what does 11 billion miles even look like? It's almost impossible to wrap your head around. Well, here's a pretty wild comparison that really puts it in perspective. 11 billion miles. That's about the same distance the Voyager 2 space probe has traveled since it launched all the way back in 1977. The one that left our solar system? We'd basically have to match that entire journey, but on our highways. Or, okay, think of it this way. If you had a fleet of 100 cars and they were driving 24/7, nonstop, it would still take them over 500 years to cover that distance. I mean, by then, the tech would be ancient history. The bottom line is, it's not just hard, it's statistically and physically impossible. So, if we can't just drive our way to safety, what's the alternative? I mean, there has to be another way, right? How do we break through this billion-mile barrier? Well, the good news is, the whole way of thinking about this is shifting. The industry is moving away from that brute force, how many miles did we drive, mindset. Instead, it's all about a smarter, more targeted approach. We're talking intelligent design, logical proofs, and really, really fast testing. One of the really promising ideas here is something called responsibility-sensitive safety, or RSS for short. Basically, instead of just driving around and waiting for bad things to happen, RSS is like creating a mathematical rulebook for safe driving. It defines common sense stuff like what a safe following distance is or who has the right of way and turns it into pure logic. And this is really how it works. You know all those unwritten rules of the road we follow? RSS just turns them into hard, verifiable code. So it'll set mathematical limits for things like keeping a safe bubble around the car or how to merge onto a highway without cutting somebody off. The absolute key here is that the system is designed so it can never be the one to cause a crash. It might have to react to a human mistake, but it won't be the one making it. You're proving safety by design, not just by logging miles and hoping for the best. Then there's another really important idea called SOTIF. And this one tackles what is, frankly, the scariest part of all of this, the unknown unknowns. You know, the problems you don't even know you have yet. It's basically a systematic hunt for those weird fringe risks, like what if a low-setting sun or flex off a wet road in a way that totally blinds a sensor? The goal is to find those unknown dangers and turn them into known problems that you can actually solve. When you put all this together, these methods like RSS and SOTIF, plus incredibly powerful simulations, it's a total game changer. Developers can now test millions of dangerous, weird edge cases in a virtual world all in a single day. They don't have to wait for years for some one-in-a-million event to happen on a real road. It's a fundamental shift from being reactive to proactive. So, where does this leave us? What does this all mean for the road ahead? Well, these new ways of proving safety are completely changing the conversation around self-driving cars. What we're seeing is that the challenge is shifting. It's moving away from being a purely engineering problem. How do we hit this magic number of miles? And it's becoming more of a societal one. The engineers are figuring out how to solve their piece of the puzzle, but that leaves us with a much bigger, much trickier question. Okay, so let's just boil this all down. What are the key things to remember? First, proving self-driving car safety with mileage alone is statistically impossible. The numbers are just too big. Second, the focus is now shifting to smarter ways to verify safety, using things like RSS and SOTF. And finally, this means that safety isn't really a number you hit, it's a whole process of design, testing, and regulation that we have to trust. And that brings us to one final, really thought-provoking question. We know now that we can't just drive these cars until they're statistically perfect. That's impossible. So the question we're all left with is, how safe is safe enough? Especially when we know the alternative, us humans, are far from perfect. That's not just a question for engineers, it's a question for all of us.